right, so today I'm going to just go over some of the basics for the take-home gas laws lab that you're going to work on some today in class and then on your own if you don't finish. All right, so for the first part, you're going to need a tape measure and a balloon. This is one of the little water balloons in your kit. This is not a full-size balloon. It's one of the small ones. So you can see that it's, only a couple of inches long. All right, so you're going to blow that balloon up about halfway. You want it to still have some room for more air. All right, so this is what mine looks like. All right, and then what you want to do is measure the circumference of the balloon. That's the width the whole way around, and kind of keep a note or make a note of how tightly you pull it and which direction you measure, because you want to do it consistently each time. So mine is about 24 centimeters around. Okay. After you do that, now you can use that circumference for this balloon to calculate what the volume is. All right, that equation is in your Google Doc. All right, and that's going to be an approximation because you can tell this isn't quite an exact sphere. All right, then what you want to do is either stick it in the freezer for a few hours. Your lab says 30 minutes, but we found that that's not actually enough time to make it cold. So you want to stick it either in the freezer for a few hours, or you can get a bowl and put ice water in it and then put the balloon in the ice water, and if you just let it in there for a minute or two, it will adjust to that temperature. So either way works. All right, and then once you do that, you're going to measure the circumference again to get a new volume at the colder temperature, right? Then if you've used the bowl, empty the bowl out, and you want to get warm water or hot water. Okay, not hot enough that it's going to melt the balloon and cause it to pop, because then you'll have to start over. But you can either get the hottest water from your tap, or if you have a plastic bowl that's microwave safe or a glass bowl, you can just put water in it and put it in the microwave for a minute or two until it's nice and warm. And then you'll put the balloon in the warm water, measure the circumference, calculate the volume again for that temperature. All right, so that's experiment 1. And while you're waiting for the balloon to get cold, you can move on to experiments 2 and 3. So the second experiment, you're going to need a cup of water, like this. Okay, it doesn't really matter how full it is. I did mine about 3/4 of the way up. Okay, and an index card. There are 2 of these in your lab kit. Right, so put the index card on top. Right, if you've never done this before, I recommend doing it over a sink. Right, you want to hold the card flat, tight against the cup, okay, so there's no gaps, right? Flip it over, okay, and then once you've done that, you can let go and the card will stay on its own. All right, if you don't have a tight seal the whole way around, this won't work. And this is a relatively inexpensive index card. I got them at the dollar store. So if you let it sit for too long, the index card will get soaked and then it will fall off. All right, so that's why I recommend doing it over a sink. You can see I even spilled a little bit of water flipping it over. All right, and then you're going to use either your ruler or your tape measure to measure across the diameter of your cup, and then divide that in 2 to get the radius to do the rest of the calculations. All right. Most of the time we use centimeters, but for this particular experiment, we know the air pressure in pounds per square inch, so you're actually going to use inches for this part. All right, and then the last experiment looks at pressure using the syringe. Okay, so you need the cap that came with your syringe, so if you don't have that, find it, okay? And then you're going to pull the plunger all the way out. Okay. So the first thing we're going to do is look at how air works. All right, so you put the plunger in about halfway, so it's about 30. Okay, put the cap on. Okay, it is possible that you're going to build up pressure in here, and it's possible that the cap will fly off. So I recommend that you wear your safety goggles while doing this experiment. All right, so put your safety goggles on, and just be careful that you don't like break your mom's floor or ceiling lamp or anything like that. Okay, so with air, all we have in here is air, just from the atmosphere. So it's a combination of nitrogen and oxygen and carbon dioxide. Okay, so you can push in, and you can see that air is a little bit compressible. We can push it into about 20, maybe even all the way to 10 milliliters, okay? It also will expand, and I was holding the cap on while I did that. It also will expand, so we can pull it out pretty far as well. I can get it out all the way to about 60 milliliters. All right. So that's part one. Okay, so you can see that we can easily change the volume of the air in our syringe. Okay, and when we do that, we're actually changing the pressure. And so I now have the syringe all apart again. I'm going to take my marshmallows. You should have these in a little baggie in your kit and throw them in. Don't put the cap on yet. Put the plunger back in about halfway again. Now put the cap on. All right. And what you'll see is, I'm going to turn it so you can't see the numbers, so you can see the marshmallows. Hold this tight. When you push it in, let me make it so they're not all lined up. When you push this in, you can see, oh, my cap popped off, so I lost my pressure. Right, but you can see that we're squishing the marshmallows together, right? That's because the air molecules in our syringe are getting squeezed in tighter, and so they're going to be pushing on the walls of the container more and also on the little marshmallows. And marshmallows have a lot of air in them, so they can be compressed as well. All right? You can also see, my lid popped off again. You can also see that we could pull this out, right? And now our marshmallows actually get bigger because there aren't as many air molecules pushing on them and squishing them together. All right, so this is just kind of a visual of what's happening with the pressure because marshmallows have a good bit of air in them. All right. And then the last two experiments involve using water. So put your cap on and pour some water in. All right, I did it about half full. Right, so then I'm going to put the plunger in, and now I'm going to turn it upside down, all right, to let some of the air out of my syringe. All right, and then put the cap back on. All right, so now we have a little air in there, and you can see we can't really compress the water the same way that we could the air. You may also want to do this over your sink so that you don't end up with water all over wherever you are. And at the same time, we can pull out a little bit because there's some air in there. But for the most part, we can't really expand the water either. All right. And then the last part, you can do the same thing with soda or seltzer, something that's carbonated. And I want you to take a look at what happens with the bubbles in that liquid when you do this experiment. I'm not going to do it for you. I want you to take a look and see what it looks like. Okay, so that's just the gist of the gas laws labs that you're going to do today. All right, and if you have any questions or need help with the calculations, just send me an email or we can schedule a chat.